Okay, today I'm gonna solve again another really cool problem. So it basically tells us to find all the duplicate integers in an array. And we have to do that in constant time and as well in linear time, and also without using any extra space. So we need to have a space complexity, a constant space complexity. So that is the the gist of the task. So I mean, it's not asked so frequently, but it's asked by Amazon and Microsoft and Apple these amount of times in the last 6 months. So yeah, so basically, given an integer array of length n, where all the integers are in the range of 1 to n, and each integer appears once or twice, return an array of all the integers that appear twice. So we need to return an array of all the integers that are duplicate, right? So they will only appear twice if they're duplicate. And the most important detail here is that all the integers are in the range of 1 to n. And this is very important because the gist of having this like nice solution is that we have this array has this property. So here are some examples, are pretty self-explanatory. So for example, here 2 is duplicate and 3 is duplicate. 1 here is duplicate. There's no duplicates here, so we return an empty array. So that's kind of like our base condition. And then we also have here 100,000. So n can be between 1 and 100,000 elements. Okay, so the main idea with this, so if I am we'll copy this thing here, and I'm gonna spread this out. I'm gonna spread this out. Okay. And so the good thing here, okay, I'm just also going to bring this here as well. So range equals 1 to n. So here, for example, we have 1, 2, 3, 4, 5, 6, 7, and 8, right? We have eight characters, and the largest integer is 8, right? So this is basically, we can see that property. So one cool way to solve that is that we're gonna modify this array in place. And that's a good trick when we have these constraints of solving a problem with constant space. And then we can do that because, I mean, we're gonna do basically the following strategy. So for just the sake of labeling this, I'm gonna label here the index 1, 2, 3, 4, 3, 4, 5, 6, and 7. So the way we're gonna do that is that we're gonna map basically the numbers, the integers, the numbers that are stored in this array as to their corresponding index. So what does that mean? So basically we are going to have like a little function or mapping that says let's say target index equals I minus 1. So for example, here we have 4, right? And then that means that 4 will be actually mapped to index 3, right? Because of course this will be like nums, or input, let's call it input. I minus 1. So here 4, right? So when I is 0, we have 4, and 4 minus 1 is 3. So 3 will be directly mapped to index 3 here, right? To this position. And then similarly, for example, when this integer 3 will be mapped at this position here, right? And then this integer here would also get mapped here. And then this way we can like easily see or identify the duplicate numbers, right? So the other thing that needs to be done is once we're like iterating through this array, we're gonna mark each item as visited, right? So for example, here 4. After that, we have to mark the index corresponding to 4 that was visited. So then this one will be 7, right? So it will be -7. And then, for example, when we are in 3, so 3 will be mapped to this entry, right? So once it's finished visiting, this entry will be modified to -2. And then, for example, once we're in this 3, and we know that the index that is mapped to, or the element that is mapped to, is negative, we know that it will be duplicate, right? So that's basically the trick, the cool thing about this strategy, right? So yeah, and then of course, like an easy and a very easy to find way to find if like anything is duplicate in like in a collection is to do a nested for loop and like check, right, for every element, do I have a duplicate pair? If yes, well, we have identified one. But of course, like that will not pass our times constraints in general, like these n-squared algorithms will again not pass when we have these types of constraints. They're with very, very small constraints like 100 or and below typically. And yeah, I'm gonna do also this stuff I'm gonna start mixing up also with TypeScript as well, because I'm supposed to start to learn this language, and I'm gonna leave this auto completion on, so I kind of have a more more of a hint that I'm doing the syntax correctly. So let's start this implementation. So I'm gonna copy this thing here as usual to have it as reference. So we're gonna have it here. Just want to space it out a little bit as well. And I'm gonna put the indexes here. 0, 1, 2, 2, 3, 4, 5, 6, and 7. Okay, so let's just to do this implementation right now. So we're gonna have a for loop. So we need also to have access to the index. Or actually, I don't think we need to, but so I think we can do for bar num of nums, and we're going to say constant target index equals nums. Oh, actually no, not nums. We're going to say nums minus 1, right? Number. And I'm wondering if do we have an integer type? Well, this is, yeah, this also seems to be used for integer types. Okay, so n num minus 1, right? So that will be our thing here. But then also one edge condition is that we need to take the absolute value, right? The absolute value of num, and then we have to say -1, subtract -1. And it's because we're basically, sometimes we're marking like each of these things as negative, so we need to take the absolute value, because then we're going to have a negative value and we're going to have like an index out of bounds. And then the other thing we have to do is so if the value, right, if that mapping, so num's target index is smaller than 0, is negative, right? okay, particularly the parentheses, is smaller than 0, we know we found a duplicate, right? So we are going to have here an array, constant duplicates, number equals, and we're gonna add that. So push, and we will add this thing. And of course, we also need to take the absolute value. Okay, and then we will mark it as visited, right? So we will mark this thing as visited. So we need to say this times equal to -1, right? So we yeah, and then we return duplicates. So if we walk through, do a dry run. So this is when we are 4 minus 1 is 3, so 3 is our target index, so that will be -7. So -7 is not smaller than 0 at this moment, so it hasn't been previously visited. So we will add this to -7, and then the next one is 3 minus 1 is 2, so 2 is our target index, so it's not negative, so we have this one, and then we have this 2, right? So that's where we take the absolute value here. So now 2 minus 1 is 1, right? So this is our target index, so this is not negative, so we have here. And then we are at 7, so 7 minus 1 is 6. So 2 is at index 6. 2 is at index, actually no, kind of, these things are shifted, so let me reorder. Okay, so sorry, so we are at 7 minus 1, 6, of course, and then we have 3, right? So 3 is not negative, so we mark it as negative, right? And then we come here to 8, so 8 minus 1 is 7, and then we mark this as negative, and then we're here at 2, right? So 2 minus 1 is 1, right? So now we have, it has already been visited. So then we know 2 is a duplicate, right? So then 2 will be added, right? And then we're here. We are, yes, so then we add this, and then we mark this also as negative, and then here we're our last element, which is 6, or sorry, 3. So 3 minus 1 is 2, so we're our index 2. So we already visited this one, right? So it's negative. So then this one will be 3, right? Which is the expected result, 2 and 3. So that's just the dry run for this. So let's run this code. And yes, so it accepted these test cases here. Cool, so let's submit this. And yep, that's everything passed. And that's it. That's the gist of this algorithm, which I think it's actually quite an interesting strategy. Of course, giving this constraint here. Okay, so that's it. That's it for this one.